Alright, we'll finish 10.8 today, but why don't we go back? It's been a while. What we did on Wednesday, right? We had Friday off because of the Veterans Day, but now in 10.8 we have explored complex numbers. We learned about what I means. I is basically square root minus 1. We don't know what square root minus 1, so they made up a symbol for it and they went with one of the letters in alphabet, I. Whenever from now, when I said whenever you see I, you will remember a radical with minus 1 inside. And whenever you see I squared, you will make it perfect number minus 1. Okay? So having a square around I is great. You no longer have a complex number. It's just a regular number minus 1. But what happens if you have other numbers other than 1? If you have minus 2, minus 10, minus 100, what do you do with them? Idea is the same. You treat this minus. It's like a virus. You sanitize this prison by bringing minus out as what? I. And now the prison looks like jail, looks like a regular jail with a positive number. You simplify this and try to compute root b, square root b as much as possible. Okay? How was the trick with it on Wednesday last week? Such as minus 169 was minus 1, no, not minus, I, no more minus, okay? I 169, we figured out 169 is square of 13, so this is I times square of 13, and square root and square cancels, like you're paying off the bill and you're posting the bill and 13 comes out. I 13, we usually like the number in front. 13I was the answer. We did root negative 17 same way, and then we started multiplying those infected jails, or added or subtracted that, but you cannot add, subtract, multiply those jails until you cure them or sanitize them. Before anything else, you need to take those minuses out as i's, then simplify and combine or multiply terms. Okay, that was the trick. Do not rush to compute these. Always make them radicals positive by bringing minuses out as I, and then do the required work. And then we took a look at what happens to other powers of I. We already know these two. I is I squared is minus 1. These are already given to us in the definition. But what happens if we have third, fourth, fifth, or 100th power, like I to the 69? And we've checked out that with the help of this table, they keep getting the same values over and over every 4 terms later. Like 1, 5th, and 9th, 4 terms difference is all I. 2, 6, 10 is minus 1. 4, 8, 12 is all 1. So every time you add a 4 to the top number, we will keep repeating the same number. So how did we discover I to the 69 then? Did we complete all this table all day? No. We divided 69 by 4, checked out what's left, remainder. I don't care about the quotient, but 4 goes into 69 15 times, and you did the math here, and the remainder was, what was it? Not 4, of course. It can't be 4. It should be 0, 1, 2, or 3. It was 1, right? And we checked out what is in row 1. If you have 1, you pick this. If you have 2, remainder 2, you have this. If you have remainder 3, you have this row. If you have remainder 4, wait a minute, can we have a remainder 4? No, you can't have remainder 4. This is remainder 0. If you have a remainder 0, then you pick this result, 1. So 1 means I. The result was here, I to the 1, right? Okay? 1, 2, 3, and this is remainder 0. Okay, so we all computed this. I think they were all I. And we defined complex numbers as combination of regular numbers plus be many i's. Whatever b is, it can be decimal, it can be another radical, real number, or whole number, negative number, but it's attached I. This combination is called complex number because it's really complex. It's a combination of two things. First part is called, this number is called real part. When I ask real part of a complex number, you will read me this number. This second number b without I, exclude I please, it's called imaginary part. Imaginary part. Such as real part is minus 18, imaginary part 14 here. This is only real, no imaginary part, so imaginary part is 0. And this was imaginary part minus 21, real part was 0, no real part. 0 minus something. This is 16 plus 0i. Alright, so we caught up with the homework now. We are going to continue today with 4 operations between complex numbers. What 4 operations are they? Addition, subtraction, multiplication, and division. Addition and subtraction are the easiest. Multiplication a little bit harder. Division is the most challenging one. So I will skip after addition and subtraction, I will skip directly to division without multiplication, because in division you have to do multiplication anyways in division. So I will cover them both in division. Okay? So how do we add and subtract? Easy ones are this. You add like terms only together. So there are 2 complex numbers. Do you see that? This is complex numbers 1, complex 1. This is complex 2. There are 2 of them. And the operation, check the operation between them, addition. All you need to do is first, do not rush, group like terms together. What do I mean by like terms? Real parts with real parts are like 5 and 3 first. So I group 5 and 3 together, 5 plus 3. So this sign is coming from the middle. And take the signs in front of 5 and 3 as well. They are each plus. Plus 5 plus 3 actually. Okay? Next, I group complex parts together. Now check out the complex parts. Minus 2i, 6i here. And put a plus in the middle. Minus 2i and 6i together. Okay? Look, minus 2i, 6i. And simply perform the operations in each parenthesis. So what is 5 plus 3? That's 8. And I have plus sign coming up. What is minus 2i and 6i make? Imagine i's are x's, minus 2x plus 6x, or y. Make them another letter if you're more comfortable with. Or consider i's as apples. Minus 2 apples, 6 apples. You have 6 apples, you lost 2 of them because minus 2 is take away, or 2 of them are spoiled, okay? How many apples you have? 4. Minus 2 plus 6. You only add the numbers in front of i's and make single I. Do not call this I squared because you have double. No. It's just single I. You're just joining the numbers in. 6 minus 2 is 4. 8 plus 4i. That's it. Any questions? Okay. Ready for the next part? Subtraction. If I want to order, I called addition and subtraction easy, but I changed my mind. Subtraction is not easy, it's moderate. I mean it's harder than addition because there is a tricky part we need to pay attention. So how I explained it earlier. I said take 2 parentheses and group them together, right? I will group like terms together. What are like terms here? Real parts with real parts. So it is 3/4 first one and 3/8 second one. But what is the operation I'm gonna put between them? Yes, you will move the sign to in front of the second number coming in here and decide the sign in this first parenthesis that way. So this is plus 3/8. Minus plus 3/8 makes minus. Be careful, okay? Second, we are going to now group i's. This is, no, sorry, this is wrong. Go with the sign in front. Positive 5/3 I. Okay, what is the second number? Is it minus 4/5 I? Is it? No. We need to consider this minus and this minus together and move them in together. So minus and minus makes this thing positive 4/5. If you do what I said, the sign between these two groups must be positive. Because you have already passed this minus into this second numbers and reflected it into the second numbers as minus 3/8, positive 4/5. This minus is gone. If a minus is gone, a plus replaces it. I'm already carrying the minus in. And I'm turning it into an addition. I'm turning a subtraction into addition. And I will just do regular addition afterwards. This is method 1. But some people don't do that. Okay, I hesitate to give the second method because if I give 2 methods, you guys start confusing. So don't listen if you think you're gonna confuse. If you got this right, if you can do this all the time, if you're happy with this, do this. Don't listen to second one. But the second idea is, I will do it underneath this guy. So I'm cleaning this. Here's the second grouping method here. Keep this sign as it is. Only combine these like terms with their original signs. 3/4 plus 3/8. And then 5/3 with negative 4/5. I'm keeping original signs, no changes. No change on this side. Do you see the difference? Here it was plus flipped signs of this, flipped signs. But here minus, same sign, original sign, minus, minus. But in the end they happen to be same. Okay? So, however, when you do the second way, you need to first combine these, and then you don't forget to pass this minus sign. You need to flip the sign. So it's kind of tricky on this one. I prefer the first one, okay? So I'm not gonna do this second way. I'm just giving you, if you like it, do it. But my convention is to use the first method. Always, before you forget, because you forget to pass the minus sign later, before you forget, we pass the minus to both terms and reflect those signs here. 3/4 minus 3/8. Look, it's easy. 3/4 minus 3/8. 3/4 minus 3/8. And then 5/3 minus minus 4/5. 5/3 minus minus 4/5 makes plus. And what do we do with the sign in the middle? We turn it into plus. Okay? Next, you need to combine these two terms. So how do you subtract two ratios, two fractions? We subtract tops and bottoms. Is that right? Is that how we do it? So it is 3 minus 3 is 0. 4 minus 8 is minus 4. Do you all agree? I just subtract side by side. Correct? No, this is wrong. We don't do subtraction that way. Subtraction or addition, no matter what you have, subtraction or addition, you need to have these two denominators same so you can subtract. So this is 4, this is 8. I need to make 4 into 8 by multiplying both sides by 2. This is 3 and 5. I need to make them both the same. So how do I make them both the same? 3 doesn't go to 5. But I could multiply it with 2 and make 6, but no, it's not gonna make 5. So I need to multiply both with something so they can meet, and they will meet at 15. 3 goes with 5. 5 goes with 3, so they can make 15. Least common multiple or common denominator of 3 and 5 is 15. You basically factor each number and see what's different factors in each, and you complete the missing factors on each part. 3 needs 5, 5 needs 3. Here you didn't need that because when I factored 8, it's 4 and 2. 4s are matching already. Only thing missing in the 4 was 2. I made it up. I made up 2 on top and bottom, and they match now. So this thing is 6 over 8 minus 3 over 8. Second one is 25i over 15 and 12i over 15. Okay. Next, you now can add side by side. Only on the tops though. You repeat the denominators. This is 8. You don't subtract the denominators, only tops. And you get 6 minus 3 on the top. And this is 25 plus 12. And you repeat the same denominator, 15. And what do I do with the i's? I copy one of them here. Okay? You only add the numbers in front of the like terms, like x and x, 25, 15x, 12, 15x. You copy one x here. Or apples. 25 over 15 apples, 12 over 15 of an apple. So you copy one right here. Okay. 6 minus 3 is 3. 25 plus 12 is 37. This is it. So this is a very comprehensive question because it also checks your knowledge of fraction, addition, and subtraction, right? It's a good review. Any questions? Alright, let's substitute this. So how do you write up your answer? How do you make that I notation? First, 3 over 8. Alright. Let's clean this up. 3 over 8. Plus, make 37 over 15. And then go to the right and just put the letter I. Right? Any questions? Okay. I will explain how multiplication is done. There is no tricks on this one. It's just something you are familiar with actually. Follow this example, please. What is this operation called? There are two terms here. This is a complex number 1. There is a complex number 1, another complex number 2, and the operation between them is product, multiplication. Do you see that? Although you don't see nothing between two parentheses, there is always secret multiplication. What is this procedure called? I see arrows popping up. FOIL. So we do multiplication by foiling actually. It's nothing new. Maybe multiplication is kind of the easiest. It's just long. It's too tedious. You need to multiply 4 pair of numbers. 10 with 2, 10 outside, 10, 3i, inside, minus 5i, 2, and last terms, minus 5i, 3i. F, O, I, L. Well, there are a couple of things you need to pay attention though. Where? When you multiply O and I and you compute O and I, what do you get? 30i plus 30i minus 10i. These are like, do you see i's? Like 30 apples, 10 apples. So you can combine them. You need to combine them. You must combine them actually. It's not optional. Don't leave your answer here. Most people stop here. That is wrong. Don't stop. You're not done multiplication. You need to simplify. So you will combine these two terms all the time. And most people think I can't compute I squared, because when it's I times I squared minus 5 times 3 is minus 15. No, you can. I squared is, what is I squared? By definition, square of root minus 1 is minus 1. Remember, I squared is minus 1. So you need to make this minus 1. And even better, minus 15 and minus 1 makes positive 15. And this time the first and last terms are like. So you need to combine them into 35. Again, when you FOIL a complex number multiplication, first F and L will be combined on the end always. Although L looks like have i's, they will disappear because I square will be minus 1. O and I will be combined as well because they will each have I. They are like as well. So last numbers, first and last numbers, middle terms will combine respectively. Okay? Make sense? Can I combine 35 and 20 and make this 55i though? Can I combine these? No, they are not like. This is a real number. This is 20 and I are glued together. You cannot separate them. You cannot think them different separately. 20i is something bulk together. So they won't combine. You cannot make 35 plus add it into 20. Impossible. Alright? That's multiplication. Any questions about multiplication? It's just foiling. We're going to repeat this in division, trust me, so I'm not solving any question about it. Going towards division next. Go to division next. Alright, I will show how you divide two complex numbers on a problem. Wait, I said two. Where are they? First off, where is the division symbol? Where is the division? Write this. This is division. But you need to have two complex numbers to divide, right? I see one already. This is the divisor. This is a complex number. Where is the other one? This is second complex number. Where is the first? It's here. Wait a minute, this is only a real number. Technically, when you look at it, it's 2 plus 0i over 9 plus 0i. This is also complex numbers. Every real number is a complex number as well. Just add 0i to it if you wish, but not necessary. Don't do it. I just wanted to show you, but you don't have to put 0i there. So this is a division of two complex numbers. Although 2 is not complex, you can make it look 1. Alright? So how do we divide that? Any clue? Any idea? I don't know. I'm just wondering what you're thinking.
Start breaking it down the way you would multiplication. Two different roots.
You want to change it to the multiplication? The bottom one? Yeah, we're going to use a multiplication, but different way. So how do you change it into multiplication? 9 plus I. Alright. Let me maybe put it this way. In complex number division, don't expect to get a regular division like we do in real numbers, like 9 over 3. You separate 9 into 3 pieces and get 3 and get a whole number and a result. Division in complex number doesn't work this way most of the time. Division in complex number is as one goal, only one goal only, which is to get rid of I symbol in the denominator. That's it. We need to, do you see the I symbol here? Once you manage to get it out of here, get rid of the denominator, you're done. There is one goal. When we say division, but technically this is not division. Getting rid of I from the denominator is the name of the operation, technically. Okay? My question is, when do I's turn into numbers? When do you get rid of them? It won't just go away like that. You can't just wipe them off and treat this is 2 over 9. Oh, there you go, you're done. No. Yeah. You need to bring in another I next to it so they can become a square and turn into -1. This is how you get rid of I. You need to bring in a friend next to it so they can glue together to I square and make 1. So this is your contribution. Your contribution. You need to bring in an I next to it. So I have an idea. If I want to bring in an I next to this guy, why don't we multiply both sides by I? It's a good idea, isn't it? I want an I next to this guy. I multiply by I. Do you agree? Can I multiply both top and bottom of an expression with anything I wish? Can I? Yes, we can. But is this the good choice? Let's do it. What is 2 times I? 2I. How do you multiply 9 plus I and I? Yeah. The wrong way. Here is the wrong way. Most people think 9 will stay as it is, and this I and I will make I squared, and I squared is -1. 9 minus 1 is 8. We are done. Most people think this is the way to do it. It's wrong. Where is the mistake here? Because this denominator has 2 pieces. You're multiplying that entire denominator by I. You need to distribute I to both spots. So it's not just 9. Then this I moves next to I. It infects 9 into 9I. Although you're curing the second one, it turns into I squared. This infection is cured. It's -1. But you brought the disease to healthy guy 9. You brought in a disease. Now how do you fix this thing? Look, you fixed this side, but you messed up the other side now. Do you see the problem? Our issue is with the I. I need to get rid of it. While I'm fixing it, I messed up the underside. It looks like these ends never meet. Shall we multiply by another I? Can we multiply by another I? You can, but you will fix this side now, and you will mess up the other side. So multiplying by a single I is not working, guys. We need to think.
Multiply just I squared, so you get 9I squared and then I cubed.
Yeah, when you do that, you try I squared, you'll get 9I squared, and this is I cubed. 9i squared is good this time because I squared is -1. 9 times -1 is healthy. But what is I cubed? I cubed from that table of powers is minus I. This one's still sick. This is still sick. Nope, no matter how high power you choose, you still can't wipe off that disease.
Would you just do the FOIL method of 9 minus I?
Yeah, there you go. There is one secret way that's gonna wipe off that whole denominator and won't cause any kind of new sicknesses. That is called multiplication by conjugate. You need to multiply this bottom and top with conjugate of this term, which is, what is conjugate of 9 plus I? 9 minus I. You see, I need to put 9 minus I, flip the sign in the middle. Now let's see how this is gonna work. Is it gonna give any kind of new sicknesses? Let's see. There are two ways to multiply this bottom. Two ways. One is FOIL. First terms outside, inside, last terms, as it's been explained here. But there is easy way to multiply conjugates. This is long, works, it works, but you will waste more time. What is the fast way?
Would you just square 9, put a minus and square I?
Yeah. If you are lucky to have a plus b, a minus b, these are conjugates, all you need to do is square both terms, a and b, and put a minus between. Look, I will apply the same recipe here. So this is the setup, this is the template. Put this down first. Parenthesis square minus parenthesis square. What do I fill in the first spot? Whatever the number you see, it goes in here. What do I fill in the second spot? Whatever you see here, without the sign. Minus and plus, forget it. What do you see on each case? It's just I without the sign. Leave out the sign, okay? It's just I. This is it. Is the disease cured? Do you have any eyes left here? Answer is no, there is no more I left here. Why? This is 81. 9 times 9 is 81. What is I times I? What is I squared? This part only. What is I squared? -1. What is negative of -1? It is +1. Okay? Any questions? How about the top? We didn't do the top, but this is a single and this is a double term. How do you multiply a single by double? Distribute this single to both terms. So 2 times 9 is 18 minus 2i. 18 minus 2i. Are we done? Are we through with division? No. 81 plus 1 is computable. What is 81 plus 1? 82. Are we done now? No. Still no. Why? We need to separate real and imaginary term I and this division into two pieces. All you need to do is pass this 82 to both terms. Because it says I want my answer A and B separated with I attached to B. So you need to really separate this denominator to two pieces. You cannot have a common denominator under the whole thing. This is A plus BI over C, another number. So what you got here is A plus BI over C. It's not acceptable. It needs to split up and separate it. So we got 18 over 82 in the first half, but 82 goes to 18. You get this. Second, you have minus sign 2 over 18, 2 over 82. And where does this I goes? I like it to the end, very end. I separate it. It's actually here. I is actually still right behind 2. But I like it all the way end here. I want to move it right here. It's doable. It's possible. You can do that. Okay? So I'm passing 2 and 82, grouping 2 and 82 with I, and then separating I here. Well, is there any cancellations here? Simplification, 18 and 82 can be reduced by 2. Divide 18 by 2, which is 9. 82 by 2, which is 41. So you get 9 over 41 in the first half. Minus, oh, this is the same deal, 1 and 41. 2 and 82 cancels. So it is 1 over 41 I. Okay, so I kept this I to the end. Well, can I still keep, if you want, in here on the numerator? Yes, you can. It's not wrong if you do that as well. Again, can I put it as I over 41? It's not incorrect. It's mathematically right. But since they really want I on the end, I'm trying to make it look like the desired result. They want A plus BI. This is your A. This is your A. This is your B, and this is your I. So 9 over 41 plus minus 1 over I. Technically, this looks like 9 over 41 plus minus 1 over 41 I. I can really push this minus into 1 and make this sign in the middle plus. But I think ConnectMath likes this answer. You don't have to show visibly a plus here. You can put this minus in front. You can bring it here, but I will test it and see. So this is, what was it, 9 over 41, and then minus, what is it, 1 over 41. I'm trying this answer. I want to try I on the top. Let's see if it's gonna like that. I over 41. Yeah, it even liked I on the top. So if you put it like this I on the top, it's still okay, acceptable. Look, we started off with 2 numbers, 1 on the top, 2 complex numbers, 2 complex numbers. How many complex numbers do you have now? Only 1 complex number, A plus BI. So you perform the division by multiplication, conjugate multiplication actually. So division is nothing but conjugate multiplication. You keep going multiplying conjugate until you no longer see I on the denominator. Okay. Alright. There is a new question, and I want you to give it a shot. There is nothing new to teach here. No new tricks. All you need to do is apply what I said earlier. Okay, you have 2 minutes. So there are 2 answers, 4, 8, which one is right? All we need to do is multiply both sides by the conjugate of what? Top or bottom? Denominator, conjugate of the denominator. So I will put, first use a parentheses please. I mean this is essential, really important. Use parentheses because there is a new group joining them. We multiply both top and bottom with conjugate of this. Conjugate means flip this sign and repeat those numbers, 1 and I. 4 plus 4I. Am I right? I flipped this one too, correct? No, this is totally wrong, but I see you guys doing this. You flip both and think this is conjugate multiple. No, you cannot multiply top and bottom with different things. It's unfair. It's like a scale balance. Whatever you're doing on the top, you must be doing on the bottom. So you cannot multiply both sides with different things. This is wrong. You need to be multiplying the top with the same thing what you put on the right. So 1 plus I. Okay. I will start with the bottom because it's easy. This is conjugate multiplication. All you need to do is set up this. That's it. Square of the first term, square of the second term without the sign. Leave out the sign and square. That's it. You're done. With the bottom. The top, however, is not that fast. We need to FOIL this thing. First, outside, inside, last terms. First terms, 4 times 1 is 4. Outside terms, 4 times I is 4i. Inside terms, minus 4i times 1 is minus 4i. Last terms, minus 4i times I is minus 4i squared. Minus 4i, actually this is 1. Minus 4 times 1 is minus 4. I times I is I squared. Okay. When we are multiplying with FOIL, what did I tell you here? You need to always combine middle terms and also last terms once you figure out I squared is minus 1. Last terms combine, middle terms combine. First and last combine, middle terms combine. Do that. First and last terms must combine because this I squared is minus 1. Minus 4 times minus 1 is positive 4. Adding another positive 4 to positive 4 is 8. Okay? Next, I told you these middle terms must combine. What do they combine into? 4 apples take away 4 apples is 0 apples. So you don't have nothing. 0i in other words.
From the bottom though, I actually got negative 8. Would that be negative 1 times 1?
Be careful. This is 1 squared. 1, right? What is 1 times 1? 1. What is I squared? You need to first yeah. This is minus 1. Just like the top, I squared is minus 1 here. This guy has double minus. Subtracting a minus 1 makes it plus 1. Okay? So this is 8 over 2, which is positive 4. Okay? Is it clear? Sounds like clear, but when you guys do this on your own, you will repeat the mistakes I mentioned here. Okay? Solve more and more questions until you're feeling comfortable.
So
you need, yes.
Nothing you can do about putting it in the A plus BI form. I mean, it's just,
Yeah, you can. It is.
but,
Here you go.
0.
0i.
You don't have to include that when you put it in.
No, I don't think so. Let's check. If it's 0i, you don't have to show it, but I will try anyways. It's just 4. Check. Yep, it liked it. You can try 0i, it will still like it. Okay, 4 plus 0i. 2 more questions left. Why don't you give it a shot before coming tomorrow? Okay, these. We will start with these tomorrow. Finish these quickly in 10 minutes, and then start review questions.